Hey guys, Mr. Mackie here, and welcome to the third challenge, the challenge week, which is the final week of my channel. And remember, we're going through challenges where you need to have knowledge from previous videos on my channel to solve them. So, here is the challenge for today. We have a line that's perpendicular to this line below, and it passes through the point 0 to 3. Now, these two lines intersect at a certain point. We need to find that point of intersection. So, how do we do it? Well, the first thing we have to do is find out the equation of this line. Do you remember how we find our gradient? Well, we choose two x coordinates and two y coordinates and subtract them. So we choose, I'm going to do these two coordinates, these set of coordinates here. So 11 minus 13 over 1 minus 0. So it's the two y coordinates subtracted over the two x coordinates subtracted. And that becomes negative 2. So we know that the gradient is negative 2. What's the y-intercept? Well, the y-intercept is the point where it goes through the x-axis, which in this case is 13. So the equation of this line is y equals negative 2x plus 13. So that's step one. We have found our equation. The next thing we have to do, though, is find out what the gradient is of our new line. How do we do that? Well, the word perpendicular will help us. Because what perpendicular tells us is if we multiply the gradient here with the gradient of our new line together, you will end up with negative 1. So what do we have to multiply negative 2 by to get negative 1? A half. So the gradient of our other line is 1 over 2. So what is the y-intercept of our new line? Well, it passes through the point 0 to 3, so that's where it goes through the x-axis. So the actual equation is y equals a half x plus 3. So we have the line y equals negative 2x plus 13 and y equals a half x plus 3. And those lines intercept. Where do they intercept? Well, let's check it out. But I'm going to tidy this board up a bit so we've got a bit more space to work out the final step of this problem. Let's see. So now that we know the equations of our lines, now we can find out how they intercept. There's two ways to do it. The first way is by the simultaneous equation approach I did, where we add and subtract them above each other. But there's another way, substitution. If we know that y equals that and y equals that, we can just replace this y with this, because they're the same thing. So, negative 2x plus 13 will equal a half x plus 3. Now we can do some balancing to tidy up the problem. So, what I like to do is I like to get rid of this 2 because a half fractions there, a bit frustrating. So we multiply everything by 2. And when we do that, we now get negative 4x plus 26, all equaling x plus 6, because you multiply that 3 as well. Now let's tidy up a bit more. Let's first move all the x's onto one side. So I'm going to plus 4x on both sides to get rid of that one. And from that we will get 26 equaling 5x plus 6. Now let's do the final bit of tidying. Subtracting 6 on both sides. I'm going to move it up here just so it's a bit neater. And from that we will get 5x equaling 20. Do you remember the balancing way we do it now? And now we divide it by 5 on both sides. And that will get us x being 4. So now that we know the x-coordinate of the point of intersection, so I'm going to put that down here, 4. But what is the y-coordinate? Well, we can just substitute that into the original equation. So I'm going to choose the half x plus 3. It doesn't matter which one you choose, you will still end up with the same answer. half x plus 3. We know what the x is, which is 4. So it's a half multiplied by 4, add 3. Half times 4 is 2, add 3 will get us 5. So the point of intersection is 4 to 5. And that's it. What you've just done today is you've not only done some division and some gradients, not only the perpendicular rules, thank you for our lovely graphing exercise, we've also managed to work out the nth term of sequences, because remember, the nth term of sequences is very similar to working out the gradient of lines. We've also done some algebra with simultaneous equations with balancing to find our coordinates. All of that in just one question. That's the beauty of these challenges. So many things to do in such a tiny bit of information given. It's incredible. Well done if you got the answer to this. Bring on our 4th challenge tomorrow. Take care, guys, and I'll see you then.